welcome to 42. Today's fortune is the Ordovician period. To be more specific, the marine life of the time and how they appear today in the modern world. Focusing on three types of animals, trilobites, cephalopods, and brachiopods, we get a picture of the kinds of creatures that inhabited the ocean waters of that time. Obviously, these weren't the only types of animals to exist. There were also graptolites, crinoids, conodonts, etc. In fact, the Ordovician period was one of the most diverse times in Earth's history, characterized by the Great Ordovician biodiversification event. Alongside the aquatic life, we'll also take a quick dive into the late Ordovician mass extinction, or in short and form known as loam, and how the loam forever changed the marine ecosystems on Earth. Before we even get into it, we first need to understand the period itself. The Ordovician period happened 443 to 488 million years ago in the Paleozoic era. It was between the Cambrian period and the Silurian period. At the time, Earth was not made up of 7 continents. It is also important to note that during the Ordovician, the climate was also drastically different. It was a lot more hotter as there was a lot more carbon dioxide in the atmosphere, contributing to the natural greenhouse effect at a greater level. And because of how much hotter it was, there was a lot less frozen water, meaning that sea levels were very high and most of the land was submerged, hence why life was basically all marine. Now we can talk about the loam. The loam was basically an extinction event that occurred in 2 pulses. These 2 pulses were both related to climate change. The first pulse was global cooling. This meant that the Earth was significantly colder. And because of this climatic change, some effects of global cooling included a drop in sea level, and because of this drop in sea level, it meant that the continental shelves, which is basically the shallow water near the land, became exposed. Many marine animals lived in these continental shelves that were exposed, and because they couldn't adapt quickly to the sudden change in conditions, this meant that many species that lived in these shallow waters went extinct. It wasn't long before the second pulse happened as well, and instead of cooling, it became global warming, and the Earth became warm once again. As an effect of global warming, we had the continental shelves flood again, and there was an increase in the amount of carbon dioxide in the atmosphere. Most importantly though, there was ocean anoxia. This is basically when there are low levels of oxygen in the water. And species that were reliant on oxygen and also species that have survived from the first pulse typically went extinct. Some common theories were first off continental plate movement. At the time, Gondwana was assumed to move to the South Pole, and obviously the more closer you are to the poles of the Earth, the colder it becomes as they face away from the sun and the heat. And because of this may have caused global cooling. Another theory as to what caused these pulses was volcanic activity, and another reason, but not the last reason, that was thought to have caused these pulses was non-vascular plants starting to move to land. And obviously these plants need carbon dioxide for their cellular processes and energy, and that may have contributed to the amount of carbon dioxide in the atmosphere. Now that you understand more about the Ordovician period itself, we can now move on to the animals. Firstly, we have trilobites. Now, trilobites are a class, and they are under the phylum of Arthropoda, or arthropods. Arthropods nowadays are animals like insects, spiders, crustaceans. In fact, the largest animal during the Ordovician period was an arthropod. It was called an Agirocassis, and this creature was very big. And you might think, they were some kind of vile predator and very intimidating, but they were in fact a filter feeder and actually helped a lot of the animals in the ocean. Basically, they were like one gentle giant instead of some creature you might assume to be very vicious. However, the Agirocassis was not a trilobite. Trilobites, meaning 3 lobes, consist of 3 parts to their anatomy. They consist of a head, an abdomen, and a tail, or in other words, a pygidium. Every trilobite has an exoskeleton made out of calcite, which I found very interesting, and in the Ordovician period, there were a lot of trilobites, right? One example being a trinucleus. As you can see from the trinucleus's anatomy, it can be classified as a trilobite because it has a head, a middle body section, and a tail. This trilobite was also a filter feeder like our fellow Agirocassis, but in comparison to the Agirocassis, which was very big, about 2 meters, double the size of almost all the animals at that time, it was only 1 to 5 centimeters and was mostly found in rocks. When loam occurred, the cooling, it, as discussed before, it exposed these shells, and these trilobites that lived in these shells obviously went extinct, and there was a massive loss in diversity. There were still some survivors of trilobites that went on to other periods, but trilobites did not become fully extinct from loam. In fact, there were some survivors, and unfortunately, trilobites did then become fully extinct in the Permian period. For our second animal, cephalopods, they are also a class, and they are under the phylum of Mollusca, or mollusks. Mollusks today include snails, squid, octopus, cuttlefish, oysters, and cephalopod as a Greek word, it means head, foot. Therefore, to categorize an animal as a cephalopod, it must have a head and it must also have arms, and these arms can sometimes be tentacles. It also must have bilateral symmetry, and they must also be invertebrates, meaning they lack a backbone. During the Ordovician period, there was a cephalopod called Plechonoceros, and Plechonoceruses, they had a very unique appearance. As you can see, they had a very distinct head, and then they had their arms. And they also had a shell, which means they were a nautiloid, a subclass under the class of cephalopods. And their shells were quite small, they weren't very big. An interesting fact about one of their features is that they have gas-chambered shells for buoyancy, so that they don't sink in the water. When loam happened, a lot of these cephalopods did fortunately live deep underwater. They were majorly affected by the loam. However, there were some cephalopods that would live in the shallow waters, and obviously these cephalopods may have gone extinct. Luckily, most cephalopods did survive the loam and also survived other extinction events throughout history, and now you can see a lot of cephalopods today. Like mentioned before, we had squids and octopuses. They're cephalopods, which is very interesting to see how, species from way long ago, we're talking hundreds or millions of years ago, can still appear today in different forms. Our last animal for today is brachiopods. Brachiopods, unlike cephalopods and trilobites, are not a class. They're actually their own phylum called Brachiopoda. Some examples of brachiopods today include Lingula and Noviocrania. Brachiopods comes from the Greek word arm and foot. They are categorized by their bilateral symmetry. They also must be an invertebrate. They typically have these unique organs called lophophores, and these are used primarily for feeding purposes. And they also have 2 valves that can be cut from the top and the bottom, unlike bivalves, which are usually cut left and right. They are also typically sedentary, meaning they don't move much, as they are typically attached either to the sea floor or to other animals. It is important to note that brachiopods are not clams, even though they share a similar appearance. Internal processes are different. An example from the Ordovician period was Lingulella. Lingulella usually sat attached to the seafloor. Sometimes, instead of just staying attached, they would dig a burrow into the seafloor as well. They would catch tiny food particles, and they were typically small in size. From the loam, brachiopods, similar to trilobites, lived mainly on the shallow water and continental shelves. So during the pulses, such as the cooling, when sea levels dropped, when these continental shelves were exposed, it caused these brachiopods to become, unfortunately, extinct. Although most brachiopods did become extinct from the loam and also from the Permian extinction event, there are still some alive today, but their numbers are very small. Thank you for tuning in to the very end. I really appreciate it, and I hope that you enjoyed learning about some of the marine life in the Ordovician period. If there is any inaccurate information or any mistakes throughout this video that you notice, please let me know so that I can do my best to correct that. References and sources will also be linked either in the video itself or in the description, so you can check that out and maybe find out more about the Ordovician period and these animals if you are interested. I thank you all for watching. Bye!